Okay, so today what we're looking at, we're moving on from the eyeball last session, and we're moving on to homeostasis. And I really like homeostasis because we take it for granted. When we looked at the nervous system and looked at reflexes, reflexes are involuntary. It means we don't think about it. We don't think about breathing. We can do sometimes, but we don't really think, well, we never think about our pupils dilating. That's what we looked at last time. So what we're looking at this time, it means keeping everything inside the same. And what I mean by that is things like, and today specifically what we're going to look at is temperature. All right, we are homeotherms. Homeo means the same, therms mean temperature. Homeotherms. Homeostasis is for everything, meaning all our conditions are the same. Where we kind of say warm-blooded animals, but we are, for a really cool word, homeotherms. Our temperature always. Oh no, something else gone wrong. I hope not. Our temperature is always about the same. I say always about. We're supposed to be 37.2 degrees internally. On our skin, we're slightly cooler at 36 degrees. So we're about 37.2 degrees. Okay. What we do is we keep our temperature the same, our water levels the same, the amount of glucose, the amount of sugar in our blood the same. It's so that our enzymes work properly. And way back, I think in year 9, we looked at enzymes, proteins denaturing, but that's for a different story. So going back to our brain, there's a part of it that called the hypothalamus, and that controls our body temperature. And what it does is, imagine it's part of the brain, it's alive, so it must have blood flowing through it, and it monitors the temperature of blood, right? Now, so it does, now here's a really interesting thing. What it does, it not just monitors our body temperature, it causes changes, all right? And there's a really weird one. So we also look, when we looked at the reflex arc, we looked at effectors. But there's something really strange. If the temperature's too low, it affects your muscles. It actually affects two muscles, two different groups of muscles. But an interesting one as well. How do you know that? Well, a really good example is when you're too cold, you start shaking. And that's your muscles shaking and twitching and generating heat. Anyway, let's look at it specifically. What happens when you're too hot? Right? Sweat glands release sweat. So whether you play sport or it's a really hot day, well, that'd be a first. I had a frozen pipe this morning. So if you're really hot, your sweat glands release sweat. Sweat evaporates. And to teach you a bit of physics, when you change from liquid to gas, your molecules are further apart. So you need to use energy. This uses energy. It uses energy to change from liquid to a gas. All right. Blood vessels near the skin widen. And that's why when you're hot, you kind of get this blushy look. And that's called vasodilation. And we expect you to know those words, vasodilation. And the way to think about it is you get redder, right? And you lose heat by radiation, right? The hair on your body lies flat, so less air is trapped, so there's less insulation. That'll make more sense when you look at when you're cold, right? So you start moving less as well. It's one of the reasons, like if you're in a really hot country and you're walking around, you go, oh my God, it's too hot, I've got to sit down. Your body wants to generate less heat. Okay, so when you're cold, your blood vessels tighten, so there's less blood near your surface. It's called vasoconstriction, like a constrictor, an anaconda, a constrictor. So if you've got less blood near the surface, you're going to lose less heat, and this is by radiation. Right? You radiate off heat. Right? Radiation. Okay, not radiation as saying nuclear stuff. sweating stops. You don't sweat when you're cold, and your muscles start tightening and relaxing really fast. You shiver. Your hair stands up, and that traps warm air for insulation. All right. Now, this is weird, is negative feedback. So there's lots of things that you'll hear. And negative means, in case of feedback, it does the opposite thing, doing the opposite thing. And negative feedback is really important. Think about it this way: when your temperature goes up, your body makes you cool down. So see, it's doing the opposite. When the temperature goes down, your body wants you to warm up. See, opposite. One goes up, the other goes down, one goes down, the other goes up. And it's always about bringing it back to normal conditions. All right, you got your key words: homeostasis, regulating your internal conditions, keeping you the same inside. All right. Thermoregulatory center. This is the hypothalamus, area of the brain that detects and controls body temperature. Vasodilations, your blood vessels widening. Vasoconstriction, your blood vessels. Vasodilation, blood vessels widening. Vasoconstriction, blood vessels getting smaller. All right. So shivering, sweat glands, receptor, detects change. So in this case, we've got a temperature sensor in your hypothalamus in your brain, in your thermoregulatory center. Effector, it causes a response. It can be either a muscle or a gland. Negative feedback, if something goes up, it makes it goes down, makes it go down. It reverses the change back to normal. And I mentioned the hypothalamus, that's the part of your brain that regulates temperature, thermoregulatory center. All right, so you know the usual 10 easy, 10 medium, 10 hard. This is all about biology, is all about pulling that data. Always go back on your information.